Hello everyone. Today we are going to learn about the Lucas test of alcohols. The Lucas test is mainly used to identify which is a primary, which is a secondary, and which is a tertiary alcohol, or in other words, it is used to identify which is a 1 degree, which is a 2 degree, and which is a 3 degree alcohol. To understand this test, we need to be aware of a certain kind of chemical reaction, which is an alcohol, any alcohol, plus when added to a hydrogen halide, for example, hydrogen chloride, hydrogen bromide, or hydrogen iodide, will form an alkyl halide, or in other words, a halogen alkane plus water. Now, halogen alkane or alkyl halides, they are insoluble in water. They are insoluble in water because of their inability to form hydrogen bonds with water molecules, and therefore in the reaction mixture we will see a precipitate which is of the halogen alkane, and that is the main observation of this test. And how long it takes for the precipitate to form is the main observation of this test. The reagent that we use for this test is called the Lucas reagent, and it is a solution of concentrated HCl or hydrochloric acid. But it also needs certain conditions, which is number 1, solid zinc chloride has to be added to the reaction mixture and it acts as a catalyst. Number 2, heat under reflux. Before we move on, we also need to know the order of reactivity of alcohols, any alcohols, towards hydrogen halides, SOCl2, which is thionyl chloride, PX5 and PX3, where X is any halogen. And here is the order of reactivity. Here is the order of reactivity. Here we can see that 3 degree or tertiary alcohols, they are the most reactive towards hydrogen halides and the other specified compounds, while 1 degree or primary alcohols, they are the least reactive. This is because while reacting, 3 degree alcohols will form 3 degree carbocations in the intermediate stage of the reaction, which is the most stable energetically, while primary alcohols will form 1 degree or 1 degree carbocations in the intermediate stage, which are the least stable energetic. We also need to know the order of reactivity of hydrogen halides towards alcohols only, and here is the order of reactivity. We can see that hydrogen iodide is the most reactive towards alcohols, which can be any alcohol, while hydrogen fluoride is completely unreactive and hydrogen chloride is the least reactive of them. This is because in hydrogen iodide, the iodine molecule is very big, and therefore the covalent bond that is formed between the hydrogen and the iodine atoms have low bond energy, or they have higher bond length. This is because due to the big size of iodine, the overlapping of orbitals to form the covalent bond between the hydrogen and the iodine atoms become ineffective. So on one side we have hydrogen fluoride, which is the least reactive with alcohols, which is our Lucas reagent, and it is constant. As we have seen, hydrogen chloride being the least reactive with alcohols. So on one side we have this as our constant reagent. So here in this test tube, if we add hydrogen halide, any hydrogen halide with an alcohol, we will get a solid precipitate in here, which will be of the halogen alkane. Now if in this test tube we add a 3 degree alcohol to our Lucas reagent of hydrogen chloride, then the precipitate of the halogen alkane formed will form the fastest or quickest. This is because 3 degree alcohols are the most reactive towards hydrogen halides. Therefore the precipitate of the halogen alkane will form the quickest. This is because the reaction will take place the quickest. So 2 degree alcohols will take a bit more time for the precipitate of the halogen alkane to form, followed by 1 degree alcohols. And therefore, with this time difference to form the precipitate, we can identify if the alcohol added is a 1 degree, 2 degree, or 3 degree alcohol. This is because with 2 degree alcohols, the precipitate forms about 2 to 3 minutes later. With 1 degree alcohol, the precipitate forms about 5 to 7 minutes later. And with 3 degree alcohols, the precipitate will form very quickly in a matter of seconds. So that is how we can identify which is a primary, which is a secondary, and which is a tertiary alcohol. Thank you for watching, and please subscribe and like the video if you have found it useful.